built off of each other.
It's still 7.4, right?
This is still 7.4, yeah. So what happens is that you can have multiple triangles built off of each other to get there, okay? So what I want you guys to look at here is that you have two special right triangles. You have a 30, 60, 90 merged with a 45, 45, 90. What they have in common is that they have the exact same hypotenuse. So what we're trying to do here is solve for the missing side length that they're asking for. So basically you have to work your way around the triangle to get there. So if I'm looking at this, I know that I'm given a value across from a 60-degree angle, but I need to find a value that's across from a 45. So what happens is that we're going to use both of our two models. We're going to use both of them to work our way through the triangle. This type of problem is basically very similar to what you did yesterday and the day before, where you used two parts. Right here, bless you, but instead of using two parts for one triangle, you're using two parts between two different types of triangles. Does that make sense? So you start with what you know and you work your way around. So here you know opposite which angle? A 60. So we start by writing out the model for the 30, 60, 90. So let's see, 30, 60, 90. X root 3, and 2x. We know that opposite the 60 is equal to 90. So now I have to divide by the square root of 3. So if I divide 9 by the square root of 3, what do you get, 3 root 3? So that means the value of x is 3 root 3. So in my diagram, what side length should I use that value of x for? Should I worry about it going against the 30 or against the 90? We'll go to the 90. So if the value of x is 3 root 3, what is the value of it across from 90 then? 6 root 3, very good. So that means here is 6 root 3. Which now means I know across from the 90 in what triangle? In the 45, 45, 90. No, because do I need it? You don't. Because, and that's the thing. And when you have these composite ones, you're going to work off of both parts. You're working off of two triangles. So now I know across from in a 45, 45, 90. So I have x, x, and x root 2. I know that across from the 90 is equal to 6 root 3. And then how do I get x by itself? Divide by the square root of 2 again. So now, in your calculator, if you divide by the square root of 2, what is it? 3 root 6. So that's the value of x, which means across from the 45s is 3 root 6. So this is 3 root 6. A lot of times in these types of triangles, when certain worksheets and whatnot, they might just spit out variables and just say solve for x. Remember, that's just the missing side length. It doesn't necessarily mean you're solving for this value of x. I just use x's here. I know that, excuse me, I know that Severino uses, I think he uses r's for his. But yeah, what we're doing here is just working our way through the triangle to get to it, okay? You're using both parts. Let's try it over. Oops. Excuse me. So as I work through the triangle here, we have a 45, 45, 90, and a 30, 60, 90. This time, the hypotenuse of the 45 is the side opposite the 30. We need to find the hypotenuse of the 36. So we're going to use both triangles again to work our way through. Now I'll give you guys a second to draw that. I don't want to get too far ahead of you here. So I have a 45, 45, 90. We know opposite which side? 45. 45, very good. You know that opposite the 45 is 10 root 3, which means opposite the 90 would be 10 root 3 times the square root of 2, which is 10 root 6. 10 root 6, very good. So now you have this part here. So you switch triangles. Oh, okay. Bless you. And now in the second triangle, you know opposite which one? 30. The 30. And that value is? 10 root 2. 10 root 6. Oh, I'm sorry. That's okay. So I know that that value is 10 root 6. And I need to solve for the one, bless you, opposite the 90. So what do I do to the 10 root 6? I multiply it by 2. So what's 2 times 10? So my answer is 10 root 6. You're working your way around a triangle to get to it. This is a, yes ma'am?
So for the one that says X, you don't have to solve for the other.
You don't have to, because you will usually see something like this when you have two triangles put together. We'll ask you for a specific side. The other ones, I'll say, just like I have been, solve for all the missing side lengths. So depending upon what it is, if it's a Pythagorean theorem problem, I'll say solve the missing side length. If it's one like this, I'll ask you what type of triangle it is, given side lengths, or the graph like we've done. Here, it could be either one, solve for all the side lengths, given one, just like we've been doing for the past 2 days. Or now it could be like this, where I'm going to ask you for one specific, molding the two of them together. Okay? It's very easy to determine what it is when the instructions are. Okay. Does that help? So basically, what we're looking at here is we're doing more than one step to get to the answer. It's a very, very common thing for these types of triangles. We use this all the time. Excuse me.
Then Mr. Murphy,
Yeah, Whiskey.
what about for the sixth?
What about? Did I need it? I didn't need, if I needed to find it across from the 60, I would just take in my calculator 10 root 6 times root 3 and hit enter. And that would have been 30 root 2, right? Yeah, 30 root 2.
So I did it right.
Yeah, if you did that, you got 30 root 2, you're fine.
Right.
But remember, if it's just asking for a specific side, you don't have to do all that extra work. Right? So, I don't know how well, let's do one of them at a time. I'll blow this up for you. Take a minute. Try this one on your own. So we start with a 45, 45, 90. Across from which angle did you know? Across from the 90. So if across from the 90 and a 45, 45, 90 is 6 root 2, what's across from the 45? 6s. So that means that this moves up here to be a 6, which now means across from a 30, 60, 90, I know now across from a 30 is 6, and I need to figure out what it is across from the 90, so it is, you get 12. It's just a matter of piecemealing it together. Across from what angles do you know and how do you go through it? What's that? Oh yeah, you get it. You get the same thing. Yep. Because square root of 2 times square root of 2 is square root of 4. Square root of 4 is 2. You work the way around it. Right? That's the whole idea of just simplifying these things as we go to set these up. Right? Not too bad? Yeah. What's that? I didn't hear all that, sorry. Good conversation. Okay. I think this will be the last one. I'm trying to remember which ones had the deposits. All right. So this one here, when you start this one out, you start with your 30, 60, 90. You know opposite which angle? You know opposite 30. So that means the value of x is 10 root 3. We need to find this value here. So that's opposite the 60, which means I just take the 10 root 3 and I substitute in for x. And I take 10 root 3 times root 3 and I get 30. So now that means across from a 45 is 30. So that's your, so if that's equal to 30, the other one would be 30, and this would be 30 root 2. And you're done. It's sometimes you'll be given across from a 30 or you'll be given across a 45. That means that is the number that you're substituting in for x. Other times, like we've said, if you're given across from a 60, you divide by root 3. If you're given across from a 90 in a 36, you divide by 2. If you're given across from a 90 in the other one, you divide by root 2. That's how you find that common multiplier. It just depends upon the problem itself to get, okay? So let's do these for this evening. There was a couple of some positive ones in the book.
Windshield wipers are on the right.
The rest of them I know you guys are sure.
Ignition's on the right too.
So this is section 7.4 in the book on page 462.
Get it to me on third.
Let's do those 9. 13 through 18, and then 23 through 25. Okay. It's basically this, it's exactly the same thing that you've been doing for the past couple of days. There's a couple of them that have the composite where you're going to do multiple triangles to it. And go from there. Alright. We'll quiz this stuff tomorrow. I don't even think the quiz will take all period, to be honest with you. It probably it might only take 25, 30 minutes if that. If we all finish, if we finish up early, we'll start talking about trig stuff, and then we'll finish our trig talk on Friday, because I want to make sure we have, because I told you guys what's going on next Tuesday, right? Next Tuesday, we're going to go down to the auditorium, and we're going to work with Seb's class, first hour also. And what we do is we're going to actually use trigonometry to measure distances. Do you guys ever see the surveying crews on the side of the roads, the guys with the tripods are looking through the stuff? basically what we're gonna be doing is the exact same thing with the original materials, which was basically a protractor and a paperclip. And it's really, really accurate for being such a crude measuring tool, okay? Excuse me, I'm sorry.
So we meet down there Tuesday?
Yeah, and we'll talk more about that when we get closer to it.
Yes, 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 yes.
Next Tuesday.